High school and college students find calculus a very challenging subject and less interesting.
So in this video, we will carefully explain the 7 rules of derivatives in such a way that it will be easily understood. And at the end of this tutorial video, we make sure that you will become more interested in studying calculus. Before we start discussing the different rules of differentiation, let us be clear here that for convention, we will use the following to express the derivatives of a function, an equation, or an expression. Depending on how the function is written, you can use one of the expressions above to denote that you are actually writing or solving for its derivatives. Rule number 1. The derivative of any constant or any number is equal to 0. As the examples shown, a whole number, a fraction, or even a number inside a square root, its derivatives is equal to 0. Rule number 2. The power rule. The derivatives of x with exponent n is equal to that exponent n times x raised to the power of exponent n minus 1. Let's solve the following examples. We will simply put the exponent before the variable x, and then the exponent is subtracted by 1. Notice that in example 1, there is no written exponent in the given function. We know in algebra that any number when raised to 1 is equal to that same number. So, the exponent in example 1, even if it is not written, is equal to 1. Rule number 3 involves a constant, which is c, a variable, which is x, and an exponent, n. In the figure, we can see that the constant remains and then multiplied by the exponent, then multiplied by the variable. After that, the exponent is subtracted by 1. So we have this example. Find the derivatives of the function 3x squared. We simply put the exponent before the variable and subtract the exponent by 1. Rule number 4. The sum rule. For this rule, we simply solve for their individual derivatives and then sum up them afterwards. Let's have some sample problems for sum rule. Find the derivatives of the following function. We shall use the following techniques. We simply put the exponent before the variable, then the exponent is subtracted by 1. After we have solved its individual derivatives, we simply add them all. For this example number 2, again, we will use the following techniques. We simply put the exponent before the variable, then the exponent is subtracted by 1. After we have solved its individual derivatives, we do the necessary operation between them. Rule number 5. The derivatives of the product of the two expressions, say u and v, is equal to u times the derivatives of v plus v times the derivatives of u. Like what we have discussed earlier, the derivatives of a function or expression can be written in this way. Let's solve this example. We assign x plus 1 as the u and x plus 3 as the v. Then, we solve for its individual derivatives. Notice that in this example, we used the constant rule and the power rule in solving for their individual derivatives. After getting its derivatives, we will use the product rule. Then, we substitute all the values to the formula. And then, simplify the expression. And continue solving, we can get the answer. For this example, again, we assign which expression is u and which expression is the v. Then, we solve for its derivatives. Let us solve first for the derivatives of u. Now we solve for derivatives of v. Now that we have solved for its individual derivatives, we will then simply substitute them to the formula. After substitution, we will continue solving the expressions until we get the simplest form. For rule number 6, the quotient rule, let's always remember it with this formula. Let's solve this example. Find the derivatives of y with respect to x. The problem involves a fraction, so we must use the quotient rule here. Again, let's assign which expression is u and which expression is the v. Then, we solve for their individual derivatives. Since we have already solved their individual derivatives, then we simply substitute them to this formula. Then we continue solving. We continue solving until we get its simplest form. Rule number 7 is similar to rule number 2. Sometimes, the expression is inside the parenthesis, like in example 1. Or inside the square root, like in example 2. In other words, whatever exponent an expression or function is being raised to, we always follow this formula in solving for its derivatives. Let's solve these two problems to understand this rule. From the given expression, let's write the value of u and solve for its derivatives. We also write the value of n. Then, we substitute them to the formula of rule number 7. After that, we simplify the expressions. For example 2, we say that whenever an expression is inside the square root, it always means that it is being raised to 1/2. By explicitly writing the expression in this way, it would be easy for us to solve when the exponent is clearly written. Like in the previous, we will write the value of u, its derivatives and the value of n. Then, we substitute them to the equation. After substitution, we continue solving the expression to its simplest form. In summary, we have discussed the 7 rules in solving for the derivatives of a function. That's all for today. Thank you for watching, and see you all again in the next video. Goodbye.